of our lovely city coming into space. And I've got to just thank everybody that made this event possible. So the first one is the University of South Australia and the wonderful room that we have. So we thank them for giving us that. Flinders New Venture Institute, driving entrepreneurial growth. We thank them for providing one of the prizes. South Australia, Microsoft Innovation Centre, South Australia, for providing one of the prizes. Thank you very much for being here. Marvell, the Mars Australian Remote and Virtual Experiment Laboratory, for providing a challenge that some of you are to work on. Lady Tech, empowering people through technology to be more human. IAAA Computer Society, reaching out to the community. And the Light Factory, who provide energy efficient lighting solutions. Just a quick note, they've got a 15% discount for everybody that's registered, so check your email in about a week. And the Mars Society of Australia. So from the Mars Society Australia, I've got John, just with a quick presentation.
Today, this is where we eventually want to go for MSO. And there are new technologies which are fast improvements. One of them is the EM drive that might eventually provide propulsion to get us there. I'll be doing a talk about that on May the 1st at all the Mars Society at London Systems, London Drive, Mile End, and you are, of course, all welcome. Thank you.
Thanks, John. And last but not least, without the volunteers, this would not happen either. So thank you to Graciela, Zachary, Marcia, Nicole, Stephen, Kim, Kelly, and Sumen, who this certainly wouldn't have happened without their help, because you knew how to get the room and everything else. So thank you very, very much. The two prizes up today. One is an entrepreneurial course provided by Flinders New Venture Institute, which is awesome. I did it in the past as well. Thank you very much. And Microsoft Spark package with free software for 3 years. Thank you very much. And for the Mars Challenge, we have a book, the Mars Survival Guide, that you will all get in that one. And last but not least, as we move into the pointy end, we have our judging panel. We have Dan Smith from Flinders New Venture Institute, Liam Elul, did I get it right? I got it right. Oh, okay. From Microsoft Innovation Centre, so they're all sitting in the back corner. Dr. Graciela Caparelli, who you've seen speak a couple of times across the weekend, and Sue Mann. And last but not least, I've stolen this slide, this format straight from Unleashed. Remember, it's statistics. So number 4 is the number of teams or number of entries that will be judged. 5 and 5 is the number of males and females that are on the crew and volunteer. 4 is the number of children aged under 13. 7 is the number of kids, young adults between 13 and 18. So we are roughly 1/3 school-aged children, which is absolutely awesome. And we are pretty much at 50-50 for men and women. So pat yourself on the back, South Australia, for being completely involving everyone. It's absolutely great. And 25 is the number of registered entered participants for the weekend. So with no further ado, Zachary will announce the names of the people in the first team. Announce the name of the first team. Please welcome to the stage, Answers Pascal.
Hi guys, we're the Ace Maths +1. You can guess who's what part.
Yeah.
Our today's topic is about more or less curiosity. Because the only reason why we are what we are is curiosity. And that's expressed in several places, like the set mission or higher mission. And we're actually not doing something bad. We are doing exploit mining. And we ask ourselves, is it a chance? Is it a danger? And what are the consequences? We want to look at that now.
So what is actual mining and how is it beneficial? Actual mining is the use of raw materials for acids and other life elements, including their earth content. So maybe wondering why asteroid mining is important and how it would benefit our society. Well, resources on Earth are limited. Our planet was born with a fixed amount of water, hydrocarbons, and other precious and industrial metals, which are found floating around in space on asteroids and other near-Earth objects. There are more benefits than just economical growth. There is also a huge benefit to the environment. Mining on Earth has huge environmental, creates huge environmental destruction, such as deforestation, chemical destruction, and soil erosion. By mining in space, we are lessening the damage that is done upon our planet and helping the environment and the future become a more sustainable place.
So what exactly are we doing? Our proposal right here has two shapes that fly out the box and mine. So we'll cross that line. We have designed mainly so far, but our primary objective is to go out and prospect the feasibility of mining from the box because it's stable, water, and fun. And we shouldn't impact it very long down the road. We have secondary objectives over analyze units, such as analyzing the composition and getting format names without marking them. Here we see a 3D model of the overland after separation from the emulsion uranium, which is stable in the investing forward. We chose the institution to be formed proximity to proximity to atmospheric part of the island of air capture and therefore substantial savings. The run is the software need to allow more control running than the power initially is. And usually uses a good weapons to result in the actual states.
Red yogurt contains scientific apparatus that will detect and identify materials for future improvements. Walker will contain a molten salt battery that powers the drill, which will be discarded after the use. Solar panels will serve as power source for the rest of the machine and the target drill found at the tip of the drill will be used as it can cut through a wide range of materials. And the Archimedes screw that detects the drill will drop the materials mined in Walker into Walker.
The way we designed the lander enabled us to take a 10 kilogram one sample, especially designed container, back to further analysis. At the end, we can say that we will be able to understand the composition of exports a bit more with data. We might find metal, nickel, iron, carbon, or minerals, or we could even find organic compounds which could lead us to the next big thing, the evolution of life. Whatever it is, we're going to learn something. That's what we want to learn something. Thank you. Insurance company.
Just want to understand, like, how that mean, the equipment will be transported there, who will operate there, how will happen?
The intention is for the equipment to be mostly automated and purchase of loans are based on the percentage packages on when the order, right? And once it lands on the grid, it's automatic controls that for predefined which we calculated it has to be appropriate volume so after the inside the order that the land and then return to the top of the order which showing back to the
Like, how much do you expect the weight of this equipment will be?
the level itself is about 150 kilograms without the fuel matching. We're expecting the return payload of about 10 kilograms. From what we worked out, the land is return from this to approximately 40 kilograms. The total land is about 200 kilos.
And this fuel weight, obviously, you consider as well. So, I mean, looking at the amount of fuel that it can carry, how long can it operate?
We're intending to be equipment going able to operate for an hour or so. We intend to do mostly the prospect of sandwich. The intention is to get one sample to benefit for analysis. There will be other sensors and there will be power fire.
The maximum time if it's operation is an hour and it's
There's not the hours, but it has solar power itself, normal operation, multi-cell battery counts,
We might call that a wrap. That's a big round of applause.
now welcome the red ladies to present.
Okay, so our team name is Red Roses, and we're looking at the marble project that Dr. Gabriella Caparelli presented yesterday. And the project was a very interesting one in that the project is looking at the rover on Mars, and the rover is currently going over the surface of Mars and giving us some information about what's sitting to the surface. Now, from our understanding, the problem that they're looking at is they're trying to find water that's gone under the surface, either as flowing water or as ice. So with our project, what we're actually doing is trying to assist with what's going on here. So I'm just going to load our slides up now. So just before the slides do open, we were actually a team of 11, so we made up almost half of what was happening here in Adelaide. And within that team, we had 2 of the teenagers. So I think the oldest teenager was around 12, so 11 or 12 is pretty there. And we also had quite a lot of men in our team, so we had a lot of diversity around the table. And that made it really interesting. We all had different backgrounds. Some of us were quite creative, some of us were technical, others had never done anything technical and convinced they were creative. And in the end, with a lot of the ideas that we had come forward, it was quite impressive to see what people did come up with. Okay, so this is what we're calling Mars plus imagination. We went to a few directions with this. Coming into a space app competition, we didn't quite know what to expect, but when we read the brief, we understood that we had some creative abilities that we could bring in. That's exactly what we did. So Mars has always captured the imagination of all those sort of scientific or sci-fi movies, attacks and all those things. We kind of went in that direction as well as looking at trying to solve the problem of the So Marvel, the actual Marvel project, is a virtual laboratory that has been designed to collect and analyze planetary data from Mars and satellites. So the goal of the project is to create a platform for cloud science to progress Mars scientific discovery, as well as conducting STEM education research. So the project uses the Mars sounding radar instrument of the USA spacecraft Mars Express. So we picked up on a couple of key words here. That's the other actually gave a presentation yesterday, and as I mentioned, we had some technical people in our team, but we also had some that weren't technical. So one of the things that we picked up on there was that Graciela was looking at dissertations and wanted to go out to school and tell them about what this project was. And as we went through that presentation, we realised that there were a lot of things that we didn't understand about this project. The other side of it is that we came to learn that it's actually a visual processing problem that they've got, where they're getting two lots of information and they've got to try and work out the difference between that information. So on the one hand, they have the information that is coming in from the radar band, and on the other hand, they've got the information coming from the simulation. And the whole thing that they needed us to help with was to actually identify where there were the points of interest in that information. And they somehow wanted to get that out so that they could get students involved in doing that research. So this is what we came up with. With the visual processing idea, we decided that we'd create a band of snap. So we thought, okay, if you're looking at visual processing and you want to have it side by side, that's a band of snap. So we have done the game concept. We haven't had enough time to develop the game. So but we decided that we were going to look at how this could possibly happen. So we thought that trying to get school students to look at a whole piece of business process design was going to be a really tough part. So we tried to find a motivation for them. We thought if we pick two school students against each other and say, right, here's the game, you've actually got to do a really good job of trying to get that data and get the other person to pay it. So you can see here on the left, we've got the rate of brand data, and then on the right, the simulation data. So the idea is that the examples go along behind the vehicle, and when they actually call those sensors into red, they would do some interaction, maybe like the space bar, and it would snap. So then they could actually register that as a person threat. We also noticed with all of the technical side that there were all sorts around the technical questions in terms of vocabulary. So we looked at the radar brand, and we know that there's something called radar brand. So we started to ask, well, how do people know what that was? So we then went on an investigation about all of the technical terms that were being used and turned it into a science communication problem. What we wanted to do was try and identify how we could break this down to conceptual research so we could actually understand what was going on. So what we did was look at a concept hierarchy. With the concept hierarchy, we started with the most technical terms. For example, here we've got subsurface radar. We then said, what do we need to know about this term? So we broke it down into radar, subsurface, and then went down to the surface level. So here we actually managed to identify the set of terms that was confusing. So I'm just going to show you next what we did with that information. Take it back one. We created an ontology. So we pulled out as many terms as we could in the scientific papers. We went about defining them all. We then looked at the dependencies between those to try and get an understanding about which one to be considered first. And then we took it and we combined it with our game. So that what we could do here conceptually was have these rover going along the surface of Mars, and we were going to find it and to interact with the Earth. And now that we're out of time, I'm going to show you the characters that we also have for our game. This is, as I said, we are a very creative team, and we just kept going and developing the concept.
So we get a big round of applause for Red Rover. Let's get one quick question from the crowd. My question's awesome.
Please welcome mining analytics for remote sensing aka Mars to present their idea.
This is surface area and I love the earth, but the but they didn't like us to go further. So, well, we go to Mars because it's the closest planet to Earth. There are many limitations, like the sensor data that, like the satellites that orbit Mars, they can only see above the surface, and the things that we can see on the surface of Mars are from globally, and we're only a few feet every day. And mobility is one of the prime limitations because rovers can't really travel much, and the satellites, they just orbit around the atmosphere. And the spacecraft that carries weight, which is too limited to carry an amount of sensors. If we resolve this, we can eliminate the need of mobility.
I would like to say that we're trying to say is the kind of approaches to not eliminate the always are the only objects that are on the surface of the planet, and they can't travel they still live on the planet. The other way to explore Mars is satellite moving on the planet, which again has limitations. So these are the considerations that we are considering. The first challenge was to identify the problems that we are trying to solve.
Yeah, so the most questions that we got were how can the vibrations be based on correlated and large of the surface of Mars. So what she's saying is that satellites, they orbit the atmosphere, so they can't really send minor vibrations that are going on to the sensors that are attached to the ground, so they can actually sense everything that's going on. The next question that we got was how can the elasticity and the plasticity of soil on Mars can be sensed in large areas of surface of the planet?
That's a particular question which needs to be answered by some technologies to inform the surface. Can't rely on the orbiting satellites to answer this question. Elasticity of the soil on the surface.
And so that is why the sensing and how can the porosity of the soil on Mars be sensed in large areas of surface?
So again, how porous is the soil on Mars? This is quite a tricky question. So again, it can't be answered made by the data coming from the orbit.
How can we sense wind movement and wind movement profiles on the surface of the planet?
Remember, the atmosphere of Mars is quite different from that. So the orbits are not the planets orbiting around Mars are not interested in the profiles of the Mars-based the profiles against to study this. There are heating factors you can have for this soil. So we really want to
some supporting questions were, how can the data be sent from geographically diverse locations? How can substances be transported to Mars? Well, these sensors can be transported to Mars by spacecraft. And how can data be sent directly from the surface of Mars? And how can those sensors be trained over longer periods?
It's a limited time to see about that. So these are the final questions that we want to answer. The solution that comes with is mining sensors. Now these mining sensors are not different and what are being used on a potential services like hormones, critical discrimination. So those mining sensors will be sprinkled around the planet, and there's not much of a change that needs to mining sensors, but there's a lot that needs to be on the algorithm. So there's a strong proof that the evidence that it works, because the first person that done this, we don't know much about Mars, we don't know much about Mars, we don't know back on how it works. So simple evidence is that the same technology is working right now with the basically my president of IoT taxation. The parameters that we'll be setting is migration, it's not very technical. So the four parameters that we mentioned are the migration, the velocity, and the process. Sensor design, the rare time that we have is the design sensor. Example algorithm and another conversion will get the serial code that we use, how it works. The advantage of design is the data is not right on the surface, not commercial. We store reliably on the planet and in the cluster. Transportation sensors quite pragmatic because they weigh less than 300 pounds like sporadic strengthening of the sensor on the planet and converting that to 15 years because they sense the feelings for a long period of time. Future work and recommendation get that. Round of applause for MIRS. One question.
I'm just referring to the one that you we also have a recommendation for a small data warehouse to find that between data from the data sources. So that's okay. Thank you very much.
Now we'll turn to Mars as an explorer.
Taking this assignment, we worked on the Masters Explorer, which we'll explain now. Listening to yesterday's presentation by about what the Mars path would be, because what they've been collecting data from this side here is Mars Press project. It's been up there for more than 12 years, and it's sending radar beams out to surface, penetrating the ground, for reflections, trying to work out what's under the surface based on that. But listening to what they were saying, it sounds as if they could have used script on communicating what they're up to, and the way of engaging people to help out with their experiment too. So we visualise, come up with visualisation of their data, so people could see for themselves what they were collecting. So this would show where on Mars each sample was taken, and possibly as time goes on, allow people to compare traces and look for anomalies under the surface. So here's a quick demonstration of what we come up with.
Alright, so this is Mars.
These are the satellite path further, and just come up traces on the ground. We found out that noise has to do with solar activity and things like that. But the context of the reflection of the Mars. So here, the simulation is based on what we know about the brain and how the brain are also affected. But up here, we've got to do the particular so that's what we're going to do. So eventually, what the system do is we put on top of the black, take this coordinate and plot it back on the map, and so that scientists can put it back in later and kind of so there's a lot more work we could have done here. There's a few obvious things. If you're not going to lay those two explain, it might be a bit more obvious than different stuff. And there's also extra data from other wavelengths that the radar works on and stuff that's that goes out towards the site rather than the link spacecraft. None of which we're showing up here, but that's what we have later on. And so we're kind of hoping that having a visualization of what this data is all about can help the market team communicate what we're up to and hopefully getting other people to help them out with their task. Question? My background is not straight, more that being an entrepreneurial start. So the idea here is that you'll have a lot of people that are focusing the data, picking out things that might be something designed to do with their service. So if you get 500 people clicking away and you start to get some noise in there and stuff, so there's an idea later to filter to power users or most devices, that sort of thing, so that yeah, and that's something we didn't get around considering, but I would imagine if you collected enough data, you tend to filter itself out because a lot of people hopefully choose particular points. So like the program that you just mentioned, I'm sure if you look to other citizen science projects and find out how they do it actually well. Where did this come from? Because to me it's like a moon, sort of black hole. Yeah, it's got the wrong colours, doesn't it? But we're sure that the data is of Mars. It's from a site called Mapbox. It's using the data. If you ask the word read, and it would be nice if they got that. So, but it should be controlled, and for one of the most interesting bits of data is only the black areas. So I show you because there's less interference with the radar that bouncing in all directions. So it's because spot areas that we suitable for analysis. Give them a big thanks. So that's a wrap for entries. So we're going to take a 15-minute interval while the judges retire. So this will be a good time to stretch your legs, take the equipment up, and we'll come back and do a door prize, and we'll get on the final results after that. The other thing, if you're a participant, I've got an entry certificate here. If you'd like to come and grab one from me during this time, it'll be handy.
Running over.
Yeah, they're gonna wait to, have a quiet yell at each other. That sounds like it worked.
There it is.
Alright. Thanks very much, everyone. Hope you've all had a fantastic couple of days. Had some very, very interesting projects and thoughts and ideas coming through. And I'm very, very pleased with what we've managed to achieve in less than 48 hours. So thanks again. One more time, we want to thank all of our wonderful sponsors and our judges who come by this afternoon to have an in-depth look at your project. So we are going to go on to the awarding of the prizes now. And what we're going to do is get the judges who essentially sponsored those prizes to have a chat, and we'll get the winning team to come up here and take a photograph with the judges as well. All your certificates and so on we'll organise to send out to you later on. Okay, so yeah, that's how we do it. So first up, we've got Dan Smith, who's the Business Engagement Manager for the New Venture Institute at Central University. Thanks very much, Dan.
Thank you. So hopefully you can all hear me quite well. So I'm fortunate enough to work out at the new Business Property building. It's a $120 million building that's been put in place with the key objective of linking the industry. So we have massive computer science engineering there, but we have dedicated levels for industry, for startup businesses. Hills have got the head office, got the Hills Innovation Centre, 3D printing, robotics, prototyping, nanotechnology, brain scanning. It's just an amazing building. And my job is to bring in business and lead them to actually technology. Part of what we do is encourage startups, particularly right from schools through to encourage people who want to start businesses. So the prize that we've got on offer today is a Team Entry to Our Venture Build program, which is a 12-week pre-accelerated program where you learn all about pitching for funding or pitching ideas, developing business models, communicating those sorts of things. At the end of that, we have twice a year, we have a big pitch night. The winner of that last time went to Austin, Texas, to the Tech Ranch, into the Microsoft and Google and a whole lot of places. Second prize went to Quantum and Ultra Innovation Centre in Singapore. So entry into that is really good, and you get 6 months based out of our building in the actual co-working space. So that's the prize on offer. It's only available for people 18 plus. So if the team that wins is a mixed team, we also have a secondary program where we can do some innovation in schools. We might have to do the whole path where we bring out mentors, young businesses, and train you up in that way. But we can negotiate that, and there might be ways to get you in the building. So I think that's everything for the prize. So with that said, the winner of this prize is going to be the Astro Mining, so ASMS Plus Plus.
Congratulations.
We will work something to that.
Yeah. Fantastic. Congratulations, Dan. Okay, and up next we have Liam Ellel who's the program manager at Microsoft, who's on the next slide.
Do this. Yeah, so essentially the prize is full stack of our developer tools and also for our cloud platform free for 3 years. Yeah, I also want to offer some time support from the Microsoft Adelaide team as well, because some of the prize winners doing some really great stuff. It'd be awesome to see it get off the ground. And the winner for that is our Red Rover. So
All right, thank you very much. So there's two more things that we need to announce. First up, Graciela will talk a little bit about the Marble Challenge, and then we'll announce the team that's going through to So Graciela.
Okay, so I've been with you guys for the past 2 days, and it's been one of the most interesting experiences of my entire life. And I'm not kidding, and I lived a very long life. So there you go. It must be true. So, I mean, it was wonderful to see all the excitement around here and the brainstorming and the novel ideas and concepts. It's incredible, which are coming from people of all generations. And it is again proof to me that space really engages people and makes you think. And also the fact of doing so together with other people who feel the same way and who have the same passions. It's really invigorating. And it also shows that when we get together, we can perform much better than the sum of us all. So it's been inspiring for me. Thank you so much for all of that and allowing me to be part of this experience. And the first thing I want to congratulate the Red team. They got completely right the STEM mission, and I am very, very pleased that Microsoft will work with you guys to develop this mission further. And as a member, we will also be working together on the global Marvel team that will involve also our city branch and our international partners. But it is great to see something that will happen in Adelaide as we progress. So I would be clearly very guide on that. So congratulations, that's fantastic. I'd also like to mention specifically the team that entered the competition last. They were fantastic in their innovation and in their ability to think out on a project that we didn't think about. Something that's you guys. So even though it was not part of the competition officially until you guys entered, but it's been really eye-opening in terms of looking at the problem that scientists and engineers from major space agencies have tried to figure out for very many years. And so I certainly intend to follow up with you guys. I am not an engineer myself, but in our society, Australia, the president of the society, John Park, and some of his research team members, they're also building small spacecraft for landing on Mars. And I'm pretty sure that in their mind, the concept of small miniaturized sensors is very important, and they're developing it and testing it among other things in Australia in the most dangerous ranges, as well as in other parts of the world. So I will certainly keep in touch with you and keep you in touch with John, who will have possibly a way to involve you also in this project. So we want to see this idea continue, but it's not really something really interesting. And therefore, I want the two girls representative of that team to come over here. Get us and experience, so you can decide which group you want, or you can, read one and then swap. That's the two of you. So keep that in mind, and we'll be probably communicating with the talent. But I am sure that there is room also for all generations in further developing that idea. And see what it takes. You never know. At the very least, testing in the field is ready. So thank you so much, guys. Well done. And the Marvel Prize will go to the last team that spoke. Over there, so I would like you guys to come over here. We mentioned before that the certificates for the prizes are going to be posted in the mail, but in recognition of the important work that is specifically for us, the scientists and over there, some of the maps you see on the maps express YouTube. We have some guys who can out today. We certainly be bothering you guys again. That's for sure. And so officially you're now honorary member of the Marxist technical team. So as I said, we keep in touch and we continue developing your work as well, which and this addresses among the judges as well. Certainly you can also integrate with some of the red voters. So I think something really good can come out of this experience. So thank you so much. Well done, and really you guys are awesome. Thanks a lot. Thank you guys.
I am going to hand back to Andrew in a second, but just before I do that, I just want to say that this competition would not be possible without a whole bunch of people donating a lot of their time and their expertise, and that's part of what makes something like this so great, is that people do it because they love it and because they're passionate about this topic. And in particular, I would like to all please thank Andrew, our lead organizer. He's done an amazing job, and I think you'll all agree that this was a very successful event for us this year. And also Zachary, he's been helping us a lot over the last few years as well. And to all of our volunteers, Stephen up back there, Nicole, Fiona, who spent 2 days at the time here and also organised for us to have this amazing venue, and everyone else who's here to kind of watch and support us as well. So I'm going to hand over to Andrew to get to say all the final goodbyes.
So once more, thank you everyone for coming. If you weren't here, this wouldn't happen. So give yourselves an applause. And it would be really cool if we could somehow do a group picture, but then we need to find someone to take the picture so that we can work and take it with the live stream. Well, it looks like you've got. I'll take it. All right. So Nicole wants to take a group, so we're going to have to self-organise this.
No. I do the hiding. You're all going to fit. I'm not doesn't mean you can escape. Okay, and keep. Done. Are we gonna go to the Hungry Hippo?
Yeah, if you guys want to come for a.
Anyone that doesn't know, next year Adelaide is holding the international tournament. It's the Nordic Island. Yeah. That's a